In electronics, a multiplexer is a device that selects between several analog or digital inputs, signals, and forwards to single output line. A multiplexer of two inputs has equal number select lines which are used to select which input line to send to the outputs. Multiplexers are mainly used to increase the amount of data that can be sent over the network within a certain amount of time and bandwidth. A multiplexer is also called a data selector. Multiplexers can also be used to implement Boolean functions of multiple variables. An electronic multiplexer makes it possible for several signals to share one device or resource, for example, an analog digital converter or one communication line, instead of having one device per input signal. Conversely, a demultiplexer is a device taking a single input and selecting signals of the output of the compatible multiplexer, which is connected to the single input and a shaded selection line. A multiplexer is often used with a complementary demultiplexer on the receiving end. An electronic multiplexer can be considered as a multiple input single output switch, and a demultiplexer is a single input multiple output switch. The schematic symbol for a multiplexer is an isosceles trapezoid with a longer parallel side containing the input pins and the short parallel side containing the input pin. The schematic of the right shows a 2-to-1 multiplexer on the left and the equivalent switch on the right. The cell wire connects the desired input to the output. In digital circuit design, the selector wires out of digital value. In case of a 2-to-1 multiplexer, a logic value of 0 would connect to the input, while logic value of 1 would connect to the output. In larger multiplexers, the number of selector pins is equal to the number of inputs. For example, 9 to 16 inputs would require no fewer than 4 selector pins, and 17 to 32 inputs would require no fewer than 5 selector pins. The binary value expressed on these selector pins determines the selected input pin. A 2-to-1 multiplexer has a Boolean equation where A and B are the two inputs, S is the selector input, and Zulu is the output. Larger multiplexers can be constructed by using smaller multiplexers by chaining them together. For example, 8-to-1 multiplexer can be made with 2-for-1 and 2-to-1 multiplexers, and the 2-for-1 multiplexer outputs are fed into the 2-to-1 with the selector pins on the 4-to-1s put in parallel, giving a total number of selector inputs of 3, which is equivalent to 8-to-1. The 7400 series has several integrated circuits that contain multiplexers. The multiplexers take one data input and a number of selection inputs, and they have several outputs. They forward the data input to one of the outputs depending on the values of the selection inputs. The multiplexers are sometimes convenient for designing general purpose logic, because if the demultiplexer's input is always true, the demultiplexer acts as a decoder. That means that any function of the selection bits can be constructed by logical or are in the correct set of outputs. Multiplexers can also be used as programmable logic devices, specifically to implement Boolean functions. Any Boolean function of any number of variables and one result can be implemented with a multiplexer with any number of selector inputs. The variables are connected to the selector inputs and the function result, 0 or 1. For each possible combination of selector inputs, is connected to the corresponding data input. This is especially useful in situations when cost is a factor for modularity and for ease of modification. If one of the variables is also available inverted, a multiplexer with any number of selector inputs is sufficient. The data inputs are connected to 0, D, or less D, according to the desired output for each combination of the selector inputs. Thank you very much. By the time being, that's going to be, we finished. For this moment, we finished. We'll see you in the next lesson. Thank you.